Let's solve a physics problem about forces on an inclined plane. Angela and Carlos need to determine the relationship between the normal force on a box and the angle of incline when the box sits at rest. Let's start by drawing a free body diagram. Here we have an inclined plane making an angle theta with the horizontal, and here's our box sitting on the incline. Now, let's identify all the forces acting on the box. First, we have the weight force, mg, which always acts straight down due to gravity. Next, we have the normal force, N, which acts perpendicular to the surface of the incline. Since the box is at rest, these forces must balance each other in such a way that there is no net force causing acceleration. To analyze this mathematically, we need to break down the weight force into its components parallel and perpendicular to the incline. The perpendicular component of the weight is mg cosine theta, and the parallel component is mg sine theta. Now, let's apply Newton's second law. The sum of forces equals mass times acceleration. Since the box is at rest, the acceleration is zero. Looking at forces perpendicular to the incline, we can write normal force minus mg cosine theta equals zero. Solving for the normal force, we get that N equals mg cosine theta. This means that the normal force decreases as the angle increases, because cosine theta gets smaller as theta gets larger. To verify our understanding, let's check two extreme cases. When the angle is 0 degrees, cosine theta is 1, so the normal force equals the weight. When the angle is 90 degrees, cosine theta is 0, so there is no normal force, which makes sense because the box would fall straight down. And that's how we derive and understand the relationship between normal force and the angle of incline for a box at rest on an inclined plane.